Okay, so let's continue on with our discovery of all the neat things about bones. And so now we're going to talk about the structure that protects the bones. And it's a two-layered structure, membrane, if you will, that protects the bones, sheathes them, and contains a couple of very significant layers. The outer layer is made up of dense irregular connective tissue. It's very tough, very durable, and contains some interesting components that we need in order for our muscles to work properly with our bones. So this dense outer layer provides a nice matting for the pathway of the blood vessels and nerves that are going to infiltrate into bones, and also perforating fibers. These fibers are critical for attachment of tendons from muscles to the bones. And if you've ever torn a tendon, you've got to know how incredibly painful that is. So these perforating fibers are collagen fibers that connect to collagen strands in the bone as well. And so the tendons will reach out to these perforating fibers. So by these tendons from the muscles attaching to the perforating fibers that are attaching into the bone as well. So very painful injury if you've ever experienced it. This is a nice little figure about the periosteum and shows you the tough outer layer, the fibrous layer, if you will, that's made up of that dense irregular connective tissue. So the inner layer that we just barely see here, the cellular layer, is made up of all the important cells of the bone except one. So we're going to see osteoblast here. We're going to see the osteogenic or osteoprogenitor cells in this layer, as well as the osteoclast. The only one that is missing is the osteocyte, which of course only comes about after an osteoblast has surrounded it in the matrix. So you've got all your cells necessary to manufacture new bone right here and to remodel the bone, because remember, the first type of bone that's always produced is spongy bone, and we will most likely have to remodel it into compact bone. So the endosteum, so we just talked about the periosteum. Peri means about, the osteum surrounding the bone. Endo means inside. So this is a layer of tissue that is inside the bone. Well, if we're inside the bone, we don't need a layer of protective tissue. So the outer layer that we associate with the periosteum is not found with the endosteum. Only those cell types, that inner layer, that inner cellular layer, will be found in the inside of the bone. What do we mean by the inside of the bone? Well, inside we have the medullary cavity that we described earlier. That's primarily in the diaphysis, right? The shaft of the bone. We also have it around the spongy bone. It's going to be some reticular fibers that hold everything together, but primarily it's going to be those cellular types. It lines central canals. We haven't covered those yet, so don't worry about that. We're going to be getting to those very quickly, though, in the next video or so. And then, of course, it contains the cells. That's the major thing. That's what we want. The reticular tissue is really there just to kind of hold everything in place. So now you see a good little figure on the endosteum, and we can see the presence of osteoblast, osteoprogenitor cells or osteogenic cells, and the osteoclast, the big old osteoclast. And as well, inside the bone tissue, let's say in the spongy bone, you see an osteocyte even. But it's just a single layer of cells primarily that makes up the endosteum. There are two types of structure here. We're going to be talking about these, compact and spongy. Those are your two types of bone. Compact is going to be arranged in these thin sheets called lamellae. Okay, we've talked briefly about lamellae before, but we're going to talk about it some more. And when we get into more about the structure of compact bone, we'll be talking about it even in greater detail. But lamellae are the thin sheets of bone that are deposited one section at a time. The spongy bone, remember, always the first bone to be put down, and it's made up of collagen fibers that are just randomly arranged. They aren't parallel like they will be in compact bone. They'll be randomly arranged in order to confer strength. So why do we have these two types of bones? Compact is to prevent crushing types of injuries, while spongy is going to be largely a strengthener, but allowing the bone to be lighter, because if it was still compact bone, that would be one heck of a heavy bone. Okay, and as we've talked about several times, must be important, it's always the first type deposited. Here's our histology of osseous tissue. You've already seen this in chapter 5, but just a little reminder here. In the upper right, we have spongy bone. In this area, this is the spongy bone. And then, of course, our bottom picture, classic compact bone. I mentioned the central canal earlier, and I'm getting to it before I thought I would. So here's the central canal that forms the centerpiece of this whole bone unit right here. We're going to get to that